It is time to build a workflow from scratch. But first, let us go to Workflows. Open the Getting Started folder and open workflow number 1, the one we used in a previous chapter. What I want to do now is give you an analogy so you can understand what is happening here with all these nodes connected, so it makes more sense. I will use a note node and add some info next to each node. You do not have to do that. Just watch and pay attention. I will open the same workflow, but with those notes added next to each node, and I will explain each one in detail. You probably noticed by now that when we generate images with AI, we usually download a file called a model. Sometimes people call it a model, and sometimes they call it a checkpoint. In practice, they usually mean the same thing. A model is the trained AI itself. It contains everything the AI learned during training, like styles, shapes, and how images are formed. The word checkpoint comes from machine learning. During training, the model is saved at different points in time, called checkpoints. Those checkpoints are what we download and use. So when you hear model or checkpoint, you can think of them as the same thing, the trained AI file that does the image generation. In Comfy UI, you will often see the term load checkpoint, but what you are really doing is loading the model you want to use. We can think of the model as the photographer we want to hire. The load checkpoint node is the step where we actually hire that photographer. Depending on what the photographer learned during training, they will be good at different types of photos. That is why there are so many different models available. Just like in real life, some photographers specialize in portraits, others in landscapes, macro photography, or food photography. AI models work in a very similar way. The better and more complex the training of a photographer, the more expensive they usually are. In our case, that cost is not money, but computer power. Larger and more advanced models usually need more VRAM and a stronger graphics card to run properly. To keep things simple, for now, we are hiring one photographer. We will use a model called Juggernaut Reborn, and this is the photographer that will generate our images. So now that we hired the photographer, what comes next? We need to give instructions to that photographer about what we want to get and what we want to avoid. These instructions are called prompts. We usually use a positive prompt to describe what we want to see in the image and a negative prompt to describe what we want to avoid. In Comfy UI, we use the same node for both. I just colored one green for the positive prompt and one red for the negative prompt so they are easier to recognize. The node we use is called Clip Text Encode. This node takes our written text and translates it into a form that the model can understand. In simple terms, Clip Text Encode acts like a translator between human language and the AI. It turns words into instructions that the photographer can follow during the photo shoot. Besides giving instructions on how the photo should look, we also need to decide how big the photo will be. For that, we use the Empty Latent Image node. This node is like choosing an empty photo paper before taking the photo. Here is where we decide the width and height of the image. We are defining the size of the photo before it even exists. At this stage, there is still no image. It is just an empty space where the photo will be created. Once the photo shoot happens, the final image will always respect the size we set here. Now it is time for the photo shoot. The K-Sampler node is the photo shoot itself. This is where the photographer follows the instructions from the prompts and uses the empty photo paper to take the photo. Each different seed is like taking a new photo of the same scene. The idea is the same, but the result is slightly different every time. The K-Sampler controls how the image is generated. It decides how many steps the photographer takes, how much randomness is allowed, and how closely the final photo follows the instructions. You do not need to understand every parameter right now. What matters is that the K-Sampler is the core of the workflow, where the actual image creation happens. Everything before the K-Sampler prepares the photo shoot. Everything after it finishes the photo. After the photo shoot, the image is created, but it is not visible yet. That is because the K-Sampler does not produce a normal image. It produces something called a latent, which you can think of as a hidden version of the photo. It contains the information of the image, but it is not in a format we can actually view. This is where VAE Decode comes in. The VAE Decode node is like the darkroom in photography. The photo already exists, but it still needs to be developed to become visible. So the VAE decode takes that latent result and converts it into a real image that we can see, preview, and save. Without this node, the workflow can still generate something, but you would not be able to view the final photo because it is still in that hidden latent form. And finally, the Save Image node is where the finished photo is delivered to the client. After the VAE decode step, we usually add a node that either previews or saves the image. Preview nodes let us see the result inside Comfy UI, while the Save Image node writes the final image to disk. Without one of these output nodes, the workflow has no final result. In our Photo Studio analogy, this is the moment where the developed photo is either shown to the client or delivered as the final file. Now let us zoom out and look at the entire process. First, we load a model from our disk. This is like hiring a photographer. Then we give instructions. The positive prompt describes what we want, for example, a close-up portrait of a pet. The negative prompt describes what we want to avoid, for example, saying we do not want dogs. Next, we decide how big the photo should be using the empty latent image node. This is where we choose the size of the photo before it is taken. Now let us run the workflow. You can see that all these instructions are passed into the K-sampler, where the image is actually created. The K-sampler is the photo shoot. It uses steps and different settings, similar to camera settings like shutter speed or aperture, to decide how the photo is taken. After that, the image goes through VAE decode, where it is converted from latent space into actual pixels. This is like developing the photo in a dark room. And finally, we save the image. This is when the photographer delivers the finished photo to the client. Every image generation workflow in Comfy UI follows this same basic idea, even when it becomes more complex. Let us do some quick experiments. What happens if I change the negative prompt, the instructions where we say what we want to avoid? For example, if I say I do not want a cat, it will probably give me another pet that is not a cat, and we might get a dog instead. If we run it again, it is like taking another photo of a pet, because the seed is random. Now we can change the seed to be fixed. When the seed is fixed, each time we use the same prompt, the same settings, and the same seed, we should get the exact same image. If I try to run it again, you can see that nothing happens. The result would be the same, so Comfy UI does not even bother to generate it again. If we change a setting, like the seed, then it lets us generate again, and we get a different image. If we go back to the previous seed, we are back to the same image we had before, generated with that seed. Now that we kind of understand how it works, let us click on this plus sign and build the same workflow from scratch. Double-click on the canvas and search for Load. Usually it is either Load Checkpoint or Load Diffusion Model, but in some cases there are special loaders for specific models. Now that we have the node, we select the model. Since we did not download more models yet, we only have one, Juggernaut Reborn. So we hired our photographer. Now let us give it instructions. Search for prompt, and we can find this Clip Text Encode node. Let us move it next to the other node. I like to change the color to green for the positive prompt. Right-click and clone the node, or just hold Alt and drag the node to make a copy. For this second one, let us change the color to red. Again, this does not influence how it works. It is the same node. It is just visual. For the positive prompt, I will add Close-up portrait of a pet. For the negative prompt, I will add cat. Not all models use negative prompts. Some older models like this one still use it, but you will see later that some newer models are smarter and do not need a negative prompt, and they work better when the negative prompt is disabled. Can you guess how these are connected? We have clip on both input and output, so we can only connect clip to clip. If we try to drag from the model, you can see it does not work, and the same if we try from the VAE. So let us connect the clip output from the model to both of the text encoders. Now we have the instructions for how the image should look, but we still need to define the size. Let us search again using the word empty and add the empty latent image node. There is also a newer one that we will use later for newer models, but for this workflow, we will use this simple one. I like to change the color of this node to purple, but you can leave it as it is if you want. Now we have width and height. Because we work with computers, most models work better with values that are multiples of 64 or 8. That is why we see values like 512 instead of 500. I know that this model was trained with square images at 512 by 512 pixels, so I use these values to get better results. Some newer models are trained with larger images and can generate bigger images, but that comes at a cost. Just like printing a big photo costs more than a small one, a bigger image takes more time to generate, and sometimes your PC cannot handle it. More about that later. Now let us add the most important part, where the magic happens, the K-sampler. As you can see, this node has 4 inputs, where it takes all the instructions and 1 output. First, we connect the model, since it has the same color and name. Then we connect the conditions. The instructions are yellow. Even if the names are different, we connect the positive output to positive and the negative output to negative. That is how it knows which one is positive and which one is negative, even though they come from the same type of node. The last input is the empty latent image, which defines the size of the image we want. Now we have everything needed to generate the image, but it is still in latent format. We need pixels to actually see it. So let us drag a link from the output, and you can see that it suggests VAE decode. We select it, and now the image is decoded, like a darkroom where the photo is developed. Here we also have a VAE input. In this case, the VAE model is included inside the main model, which is why we can connect it directly. In some cases, the VAE comes as a separate file, and then we use a load VAE node. You will see that later. Now, the last step is to save the image, so we add the Save Image node. Let us run the workflow and see if it works, or if we forgot something. If everything turns green, it worked without errors. There are cases where the image does not look right even if there are no errors. That usually means some settings are not ideal. People who create AI models usually provide recommended settings, especially for the K-sampler. Just like in photography, macro and landscape use different camera settings, the same idea applies here. If we look at the previous workflow, we can see recommended settings for this model: Steps 35, CFG 7, this sampler, and this scheduler. So let us change Steps to 35, CFG to 7. For sampler, we use DPM++2M, and for scheduler, we use Keras. Now let us run it again. For this seed, we get some small deformations, but for next seed, it looks fine. We will see later how to improve the results even more. Let me show you what happens when we try to generate an image that is much bigger than what the model was trained to handle. For this example, I will double the image size. On the first try, I did not even get a pet. Sometimes you might get something that looks okay, but most of the time you will see problems. You can get strange deformations, things that do not make sense, or visible mutations. If I increase the size even more, these problems become even more obvious. It also takes more processing power and more time to generate the image. The reason this happens is because this model was trained mainly on 512 by 512 pixel images. When we ask it to generate a much larger image, it struggles to understand the full space. You can think of it like the model trying to generate the image in parts. One part might look okay, but then it tries to continue the image next to it, almost like stitching pieces together, and that is where things break. That is why you sometimes see double heads, repeated objects, or strange structures in large images. Bigger images are not always better if the model was not trained for that size. But if a model is trained to handle larger images, you can get more details and better results. Let us say I add ugly to the negative prompt, so we push the result toward more beautiful images. For the positive prompt, let us be more specific. We want a dog, and we want it to be beautiful. Now when we run it, we get a more beautiful dog. Because this model is really old, like I told you, it is good for practice. But today we have much bigger and more accurate models. They produce better results with fewer deformations, but they are larger and need more VRAM to run properly. Our desktop computers are very similar to Comfy UI because they are both built around the idea of connecting specialized components together, where each one does a specific job. The CPU acts like the central processor, just like the sampler or the model does the main work in Comfy UI. The monitor is like preview and output nodes that show results. The keyboard and mouse are inputs, just like prompts and parameters. Printers and speakers are output devices, like save image or audio nodes. Routers handle communication, similar to data links between nodes. The reason we design systems this way is because breaking complex tasks into smaller, connected parts makes them easier to understand, easier to control, easier to upgrade, and more flexible. That is exactly why Comfy UI uses nodes instead of hiding everything behind a single button. Now that we know how to create a workflow, we also need to learn how to save it. If you look at the top, you can see it says Unsaved Workflow. That means none of these settings or nodes are stored yet. If you want to reuse the same workflow later, without recreating everything from scratch, you need to save it. If I click on this arrow next to the workflow name, you can see there are several save options. Personally, I prefer using the main menu. So I go to File, and here we have Save, Save As, and Export. When you click Save and the workflow has never been saved before, Comfy UI will ask you to give it a name and choose where to save it. If the workflow was already saved and you just made changes, clicking Save will overwrite the existing file with the same name. Save As lets you save the same workflow under a different name. This is the option I use the most, especially when I want to create variations of a workflow. Export is very useful because it is not limited to the Comfy UI workflow folder. It allows you to save the workflow anywhere on your computer, even outside the Comfy UI folder. The API option is mainly used when working with online or cloud-based workflows, so we will not use it here. So let us click Export. Now it asks for a name. Choose a name that makes sense to you. Click Confirm, then choose where to save it. For example, I can save it on my desktop. You can see that the file is saved with the .json extension. This JSON file contains all the nodes, connections, and settings of your workflow. This file is your workflow, and you can open it anytime, share it with others, or modify it later. JSON files are simple text files. You can open them with any text editor, like Notepad. JSON stands for JavaScript Object Notation, and it is just a structured way of writing text so both humans and computers can read it. In Comfy UI, the JSON file stores things like node types, connections, parameters, and settings, all written as text. That is why workflow files are small in size and easy to share. They do not include images or models, only instructions. If we go to Workflows, you can see I have that folder with workflows saved there. You can do that too. Go to the menu, go to File, choose Save As, give it a name, and confirm. Now if we go to Workflows, we can see the workflow is saved there. Right now it is not organized into any folder, it is just in the main list, but you can add a folder name in front of the workflow name when you save it. For example, folder name, then a /, then the workflow name. Let us see where it is saved. Go to your Comfy UI folder, then inside the Comfy UI folder, go to User, then Default, then Workflows. Here you can see your saved workflow and also the folder I created for this course that comes with the Easy Installer. You can create your own folder manually. For example, I can create a folder called My Workflows, then drag that workflow into it. Now if we go back to Comfy UI, nothing changes immediately because Comfy UI usually reads this when it starts, but we can refresh using this refresh button. Now our folder appears there, and we can see the workflow inside it. I suggest organizing your workflows like this because over time you will have a lot of workflows and it becomes hard to keep track of everything. By the way, you can also use this search bar to search for a workflow by name. We also have a bookmark icon. If we click it, the workflow is added to the bookmarks at the top, so the ones you use the most stay there. If you click the bookmark again, it is removed from the favorites list. Let us collapse this and I will show you one more thing. If we go to the desktop and open the shortcut for the output folder, or if we go directly to the output folder, you can see all the images generated so far with Comfy UI. The last one is this dog. You probably did not think about this yet, but if you open an image generated with Comfy UI in Notepad, you can actually see some code at the beginning. Just like with workflows, this happens because Comfy UI attaches the workflow to the image when it saves it. After that, there is the image data, which we cannot really read. This means that every image has the full workflow embedded in it, including all the settings and prompts. Let me drag this image onto the Comfy UI canvas so you can see what happens. Now you can see that it loads as a workflow with the file name. If we generate again, we get exactly the same image, because it uses the same seed and settings. Let us go back to the output folder and drag a different image, for example this robot. Now it loads that workflow, and if we run it, we get the exact same robot. This is very useful. Another thing you might notice is that all images start with the word Comfy UI, followed by a number. This happens because in the Save Image node, the prefix is set to that value. We can change it. For example, I can set it to Pixa, and now when I run the workflow, the image file name will start with that word, followed by a number, as you can see here. If you hover over the prefix field, you can get more information about how to format it. You can include things like the date and other values in the file name. Now let us change it again. I will add a folder name, for example my images, then a /, then the image prefix. When we run the workflow now, the images will be saved inside that folder. Let us go to the output folder. You can see we now have a folder called My Images, and inside it we have the images that start with the prefix we set, followed by a number. Now I will go back to the Workflows folder that we created earlier and delete it. Back in Comfy UI, if we refresh the Workflows list, you can see that the folder is gone. We are left only with the Getting Started folder we used for this episode. When you create your own folders and organize your workflows, I suggest naming them in a way that makes sense. You can name them by base model, like SDXL workflows or Flux workflows, or by function, like text-to-image workflows, in-painting workflows, or video workflows. Choose whatever makes the most sense to you, but organizing your workflows early will save you a lot of time later. In this chapter, I want to show you how Comfy UI is organized on your disk. This is important because sooner or later you will need to know where to place models, images, workflows, and custom nodes. Do not worry if this looks overwhelming at first. You do not need to understand everything right now. I will focus only on the folders you actually need as a user. This is the main Comfy UI Easy Install folder. Think of this as the main workspace that contains everything Comfy UI needs to run. The most important things here are the Comfy UI folder, the Python embedded folder, the add-ons folder, and the batch files used to start or update Comfy UI. In normal usage, you will mostly work inside the Comfy UI folder. If you have a different version of Comfy UI, you will not have the add-ons folder, and some of the bat files will be named differently, but pretty much everything else should be similar. When we open the Comfy UI folder, we see many files and folders. Most of these are internal files used by Comfy UI itself. As a beginner, you do not need to touch most of these. The important folders for us are models, input, output, custom nodes, and the user folder. The models folder is where all AI models live. This includes checkpoints, LoRa files, VAEs, control nets, upscalers, and more. Inside the models folder, everything is organized by type. For example, checkpoints or diffusion models for main image generation models, LoRa's for LoRa files, VAE for VAE files, ControlNet for ControlNet models. When a workflow tells you to download a model, it will also tell you exactly which subfolder to place it in. If a model is not placed in the correct folder, Comfy UI will not see it. The input folder is where you place images that you want to load into Comfy UI. For example, images used for image-to-image, ControlNet, masks, or reference images. Any image you place here will be visible inside Comfy UI when using a load image node. The output folder is where Comfy UI saves generated images by default. Every time you use a Save Image node, the result will appear here. This makes it very easy to find all your generated images in one place. The Custom Nodes folder is where all custom nodes are installed. These are extra features added by the community. Each folder here represents a custom node package. For example, we already used the RG3 node, and we will use more later. When you install nodes using the manager, they usually end up here automatically. If a custom node is missing or broken, this is usually the first folder you should check. Inside the user folder, we have user-specific data. The most important part for us is the workflows folder. This is where Comfy UI stores workflows that you save from inside the interface. These workflow files are saved as JSON files. The add-ons folder is specific to the Easy Install version. It contains extra tools, optimizations, and helper scripts. You usually do not need to touch this folder unless a tutorial specifically mentions it. You do not need to memorize this right now, but this structure might change as new tools are created by Ivo. For example, this bat file lets you link a folder with models from another Comfy UI installation. This one installs the Nunchaku node, and this one installs Sage Attention. There are also different TorchPack versions for more advanced users who need a specific version for certain custom nodes. You will also find extra tools, like one for Windows 10 that enables long paths so Comfy UI can download models even if the path is very long. There is also an update folder with bat files, but as you will see later, for the easy install version, I recommend using different update bat files. The Python embedded folder includes a self-contained Python installation. This helps avoid conflicts with other software and makes Comfy UI easier to run and update. As you use Comfy UI more, this folder structure will start to make sense naturally. In the next chapters, I will always tell you exactly where things need to go. Let us talk a little bit about updates and custom nodes. What you are seeing here is the Comfy UI Easy Install folder. This setup already includes everything needed to update Comfy UI safely. The most important rule is this: always close Comfy UI before updating. Never update while it is running in the browser. Start Comfy UI BAT. This only launches Comfy UI. It does not update anything. Update Comfy UI BAT. This updates the core Comfy UI code. Use this when you want the latest features or fixes. Update Comfy UI and Nodes BAT. This updates Comfy UI and all installed custom nodes. Update Easy Install.bat. This updates the Easy Install system itself. When should you update? Update when something is broken. Update when a node requires a newer version. Update when you want new features. Do not update right before an important project. Updates can sometimes break workflows. If something breaks after an update, you can usually fix it by updating again or removing the last custom node you installed. One important reminder: Comfy UI moves fast. Stability comes from not updating every single day. If everything works, it is okay to stay on your current version. At some point, you will mess up Comfy UI. Maybe a node breaks, or some dependencies get messed up, or an update has bugs. But remember, you can always do a fresh install when that happens. Just create a new folder and reinstall using the Easy Installer. Let us double-click on Update Easy Install. This updates only the Easy Installer and adds extra tools and add-ons. As we move forward in this series, more models will appear, new nodes will be added, and Ivo likes to create scripts that make these installations easier. When you see that the installation is complete, you can read more about the new release using this link, or press any key to exit. You may not see any changes immediately, but if we go to the add-ons folder, you can see that we now have more BAT files than we had in the first chapter. Now let us go back to the main folder and try to update Comfy UI to see if everything still works or if we break some nodes. Nodes sometimes break after an update because Comfy UI itself changes how things work internally. Many custom nodes are made by independent developers, not by the Comfy UI team. These custom nodes often rely on specific Comfy UI behavior, internal APIs, or extra Python libraries and dependencies. When Comfy UI updates, those assumptions can change, and the node stops working until its creator updates it to match the new version. So Comfy UI started after the update, but let us open the command window to see if everything worked correctly. Usually, after startup, you can see import times for custom nodes. As you saw before, all custom nodes are inside the custom nodes folder. But look what happened here. After the update, one of the custom nodes installed, like Tcache, failed to import. That means if you have a workflow that uses that node, it will not work. If you do not use that node, you can ignore it and try updating Comfy UI again in a few days to see if it gets fixed. I will close Comfy UI now and try something else. Sometimes there are newer versions of the custom nodes, and if the author fixed the issue, updating the nodes can fix the problem. So this bat file updates only Comfy UI, and this one updates both Comfy UI and the custom nodes. This process can take a while because it updates all the nodes, so I will speed it up. Comfy UI started, so let us check the command window to see if the issue was fixed. The node was still not fixed. This means that at the time I recorded this video, the update from that day broke that node. When you watch this video, it might already be fixed and work for you. Either because Comfy UI fixed a bug, the node creator patched the node, or a new developer created a replacement node. There is one more thing I want to try. We can go back to an older version of Comfy UI that did work, a version that had the right conditions for that node. The downside is that if Comfy UI released new features or nodes for newer models, those might not work on the older version, so it is always a compromise. You have to choose between keeping a specific custom node working or using the latest Comfy UI updates. Ivo hid this option so beginners do not accidentally mess up their Comfy UI. Let us go to the Add-ons folder, then to Tools, and here we have the version switcher. When we run this bat file, Comfy UI is downgraded to a previous version. In my case, it went from version 0.7 back to version 0.6. If you run this script again, it upgrades Comfy UI back to the latest master branch. Let us press any key to close this. Now that we are on an older version, it is time to check if that node works. Let us start Comfy UI, wait for the interface to load, then open the command window and check the custom nodes. Now it is fixed and there are no errors with the nodes. In a few days, I will try updating again to see if it gets fixed in the newer version. But this is basically how you update and downgrade Comfy UI using the Easy Installer. Other Comfy UI versions might require you to run commands manually, but I keep pushing Ivo to create bat scripts for these tasks. I want to spend my time generating, not typing lines of code. You will see that we have the manager here. In other versions, you might find it somewhere else in the menu. Let us open the manager and see what we have. Here we also have Update and Update Comfy UI. These are similar to the bat files, but the bat files have something extra. They take into account some dependencies needed for certain custom nodes to work, which Comfy UI itself does not handle when updating. For example, for the Nunchaku node to work, it needs specific dependencies, like a certain version of a library. The bat file updates Comfy UI, but then adjusts or downgrades those dependencies to the versions required by the custom nodes we use. Ivo tries to maintain these bat files and keep them updated so they stay compatible with the versions needed to run the workflows shown in these video tutorials. Because I am using the Easy Installer, I did not touch these update buttons inside the manager. I only used the bat files. If you have a different version of Comfy UI, you will need to use these update options, or use a bat file from the update folder instead. In the manager, you can also find the latest Comfy UI news, such as what was fixed, what is new, and recent changes. At the bottom, you can see the Comfy UI version and the manager version. Most of the time, the manager is used for managing custom nodes. If we go to the Custom Nodes Manager, we can see all the available custom nodes created by different developers. There are a lot of them. I personally try to keep the number of installed nodes to a minimum and install only what is essential or what I use most often. Some people install hundreds of nodes, but the more nodes you install, the harder it becomes to keep everything compatible, because each node can have its own dependencies and requirements. If I filter by installed, you will usually not see many nodes here besides the manager itself. However, I asked Ivo to include a few essential nodes that I use most often. One example is the RG3 custom node, which includes the image comparer node that is very useful for comparing images side by side. Each custom node has a title and a version number. You can switch versions if needed, for example, when an older workflow only works with a specific version of a node. For each node, you also have several actions available. Update only that node, switch the version, temporarily disable it, or uninstall it. You can also see how many individual nodes are included in that custom node package, along with a short description. Some nodes mention possible conflicts with other nodes. If you click on that yellow warning text, you can read more details about those conflicts. These conflicts usually matter only if you use both conflicting nodes in the same workflow. You can also see the author of the node and the number of stars it has on GitHub. Stars are given by users and usually indicate how popular or trusted a project is. Some developers are well known and consistently release high-quality nodes. That said, there have been cases in the past where certain nodes had security issues, so it is still a good idea to be careful. You can also see when the node was last updated. To switch versions, you click the version selector, choose a version from the list, click Select, and then follow the steps shown. We will not do that right now. As you remember, every custom node that gets installed ends up in the Custom Nodes folder. Here you can see all the custom nodes that come with the Easy Install version at the time of this recording. Now let us install one node as a test, just to see how the process works. Open the manager, go to Custom Nodes Manager, and search for a node called Align. We will use this as a test because it does not require special dependencies, so in theory it should not affect Comfy UI too much. Each node entry has a title. If you click on it, it opens the GitHub page for that node. On GitHub, you can see the code, because every custom node is basically Python code and supporting files. You can also check the Issues tab, where users report problems and sometimes solutions are discussed. If you scroll down, you usually find important information like required Comfy UI versions, Python versions, or other dependencies. These are the dependencies I mentioned earlier, things the developer relied on when creating the node. You also see installation instructions either through the manager, which we are doing now, or manually using commands like git clone, which simply copies the code into the custom nodes folder. Before installing any custom node, it is a good habit to read this information. Some nodes require things your system might not have, and then they will not work. Now let us install this node. Click the Install button. You will be asked to choose a version, so select the latest version. The button changes, and installation begins. When it finishes, you will see a Restart button. Comfy UI needs to restart for the node to become available. Click Restart and confirm. Comfy UI shuts down. You will see the browser trying to reconnect while Comfy UI is restarting. After a few moments, you get a confirmation message. Click Confirm. The node is now installed. If you go back to the manager, open Custom Nodes Manager, and search for the Align node, you will see that it now shows an Uninstall button. If installation had failed, you would see an Import Failed message instead. If you look inside the Custom Nodes folder on disk, you will now see a new folder for this node. It is simply the same code you saw on GitHub, copied locally. This code is what adds new nodes to the Comfy UI interface. If you deleted this folder manually, that would also uninstall the node. However, let us uninstall it properly using the manager. Go back to the manager, click Uninstall, and Confirm. Again, you will be asked to restart Comfy UI. Confirm, wait for the restart, and then confirm the browser reload. Now go back to the Custom Nodes Manager and search for the Align node again. You will see the Install button again, which means the node is no longer installed. If you check the Custom Nodes folder, you will also see that the folder for this node has been removed. This is the basic workflow for installing, updating, and uninstalling custom nodes using the manager. Sometimes when you download a workflow from other people on the internet, you will have missing nodes because they used custom nodes that you do not have installed. When you do not know what nodes they used, you can use the Install Missing Custom Nodes button. This will give you a list of missing nodes and the option to install them. That said, I personally prefer to install nodes manually, so I have full control over what gets installed. That is why I usually include a note node in my workflows, explaining exactly which custom nodes are required. Now let us look at templates. If we open templates, we can see different workflows created by the Comfy UI team. If we filter by image generation workflows and select something like a Z-Image Turbo text-to-image workflow, Comfy UI will first tell us that we have missing models. These are the AI models required for the workflow to generate images. Usually, it tells you exactly which folder the model needs to go into and gives you the model name along with a download link or a download button. In this example, you can see it needs a VAE model and a few other models. Once you download those models and place them in the correct folders, the workflow should work, assuming you have enough VRAM to run it. In this case, there are no missing nodes, so let us close this. Now let us go to Menu, then File, then Open, and open a workflow that I know uses missing custom nodes. You will see a message saying the workflow uses custom nodes that are not installed. At first, you might not see any red nodes on the canvas. That is because this workflow uses subgraphs. Subgraphs are basically nodes that contain other nodes inside them. If you have experience with Photoshop, you can think of them like smart objects. When you see an icon with a square and an arrow, you can click it to enter the subgraph. Once inside, you can see the red node that is missing. If we now open the manager and click Install Missing Custom Nodes, Comfy UI detects that node and offers to install it. For many nodes, this works perfectly. However, some nodes, like Nunchaku, require additional dependencies and extra setup. We will talk about those in a future episode. The important thing to know is that for many workflows, install missing custom nodes can quickly fix the problem. Let us close this for now. If we open the manager again, you will also see a Models Manager. This lets you browse and download models by type. Personally, I rarely use this, because a model without a workflow is not very useful. In my tutorials and on my Discord server, every workflow comes with notes explaining exactly which models you need and where to put them. The Comfy UI templates also clearly list required models and folders. So let us do a quick recap. Use update comfyui.bat to update only Comfy UI. Use update Comfy UI and nodes.bat to update Comfy UI and all custom nodes. Use update easyinstall.bat to update the easy install system and helper scripts. The update folder exists for users with other Comfy UI versions. The add-ons folder only exists in the easy install version. Inside add-ons, the tools folder includes the version switcher, which lets you downgrade or upgrade Comfy UI if needed. This is useful when a new update breaks a node you rely on. Inside the Comfy UI folder, the Custom Nodes folder contains all installed custom nodes. If you delete a folder from here, you uninstall that node. Sometimes, if a node fails to install correctly, deleting its folder and reinstalling can fix the issue. I know this is a lot of information. Do not worry if it does not all stick right away. Practice, experiment, and come back to this tutorial in a month. You will be surprised how many things suddenly make sense that you missed the first time. Regarding the Tcache node, after a few days, Comfy UI was updated again and the problem was still not fixed. There is now version 8, and even if you downgrade to version 7, it is still not fixed. Comfy UI keeps adding updates, and at some point, some custom nodes will stop working. If that node is not important for you, you can delete it or uninstall it. You can also just disable it from the manager, or drag the Tcache folder into the disabled folder so it is disabled. You can move it back out of the disabled folder anytime you want to try it again. In this chapter, I will try to simplify this complex world of diffusion and AI a little. Do not worry if you do not understand everything that is happening. Like I said before, you do not have to be a mechanic and know all the engine parts to know how to drive a car. This is the core idea behind diffusion image generation. The model does not draw an image all at once. It starts from pure random noise. This noise looks like static on a television. The model then runs a sequence of small refinement steps. At each step, a small amount of noise is removed. Early steps reveal very rough shapes. Later steps reveal clearer forms. Final steps add fine details and texture. Image generation is therefore a gradual process. It goes from noise to less noise to recognizable shapes and finally to a finished image. This slide is a simplified visualization. The real process is more complex. In practice, most diffusion models work in a compressed latent space rather than directly on pixels. A neural network predicts what noise should be removed at each step. Even though the real math is more advanced, this simplified view is enough to understand how diffusion works. It's like sculpting. You start with a rough block and remove material until the shape appears. Or, like a foggy window clearing up step by step, you don't instantly get a sharp scene. It resolves gradually. Let's open Comfy UI, go to Workflows, and from the Getting Started folder, pick Workflow 1, which is the basic text-to-image example. Even if we cannot fully see what is happening inside the K-sampler step by step, we can still get a good idea of the overall process. Remember, what we see here is a simplified representation of what is actually happening under the hood. First, we want a fixed seed. We will see later that each seed starts with different noise. Right now, we are using 35 steps, which is enough for this model to produce a clear image, like this robot. If we change the steps to 1, you can see that the model does not have enough time to remove the noise, so the image is very unclear with these settings. If we add another step, the change is subtle. Adding another one, you can start to see something forming. By step 4, we can almost see a face. We can automate this process to see the changes faster. Double-click on the canvas and add a primitive node. Like you saw in an earlier chapter, we can adapt this node for different fields. Drag a connection from the primitive node and connect it to steps. Now we have control over the steps, including what happens after each generation. Instead of fixed or random, choose increment. After each run, the value increases by 1, so now we have 5 steps. If we run it again, we get 6 steps, and the image starts to change more. As more steps are added, more noise is removed, and the image becomes clearer. Next to the Run button, there is a small down arrow. From here, select Run Instant. This means we can click Run once, and it will keep running until we stop it. You can see the workflow now runs automatically. On each run, more steps are added, and the image keeps refining. You may also notice that as the number of steps increases, it becomes harder for the computer. Just like climbing many stairs, more steps mean more effort, so generation becomes slower and slower. Soon we reach around 35 steps, which is recommended for this model to get a nice, clear image, although some results already look good around 20 steps. Now we want to stop this. Click the arrow again and switch back to Run. After the current generation finishes, it will stop. There is also another way to see a small preview of what is happening inside the K-sampler. From the menu, you can go to Settings, but it is faster to access the settings from here. In the Settings search bar, type Preview. You will see an option called Live Preview Method. By default, it does not show anything, but if we set it to Auto, we can see a small preview during generation. Let's delete the primitive node, then change the seed to Random. Now, when we run the workflow, we can see a small preview of what the image might look like before it even finishes generating. Let us change the steps to 30 and run again. You can now quickly see what is happening in the diffusion process. Even though this preview is low resolution, you can clearly see how the image becomes more and more defined as noise is removed. Now let me try something more drastic. I will use a very large image size. On some computers, this might crash Comfy UI or take a very long time to generate. I will run it again with these settings. You can see that generation is now very slow, but the preview lets us observe how the image slowly starts to appear. This is a bit too slow, so I will cancel the generation here. Instead, I will try a slightly smaller image, still larger than what the model is comfortable with, just so we can see the preview updating more slowly. Now we can clearly see the diffusion process updating every few seconds. The speed of this preview is also influenced by the sampler and the scheduler. As you may remember, models are trained on specific image sizes. If a model was not trained on large images, it treats them more like multiple smaller images stitched together. For example, our Juggernaut model was trained on 512 pixel images only. Personally, I prefer not to keep the live preview enabled all the time because it can slightly slow down generation. So I will go back to settings and set the preview option back to default. I will also reset the image width and height. You may notice that the preview is still visible. This can happen because something remains in memory. To fix this, I will press F5 to refresh the browser. Keep in mind that refreshing the browser will reload only the current workflow. If you had other workflows open and did not save them, they will be lost. Now everything is back to normal without the preview. There are still more useful things to learn. This slide explains how a diffusion model is trained. This is not image generation yet. During training, the model is shown millions of images paired with text descriptions. For example, images of cats, people, objects, lighting styles, and environments. The training process uses something called forward diffusion. Forward diffusion means gradually adding noise to a clean image. At first, only a small amount of noise is added. Then more noise is added step by step. Eventually, the image becomes almost pure noise. At each step, the model is trained to predict what noise was added. In other words, it learns how images break down as noise increases. By repeating this process across millions of images, the model learns patterns. It learns what shapes look like. It learns what objects look like. It learns how lighting and structure behave. The goal of training is not to memorize images. The goal is to learn how to reverse this process later. Training a diffusion model requires massive datasets and powerful hardware. In Comfy UI, we are only using the result of that training. Now that the model has learned how noise works during training, we can use that knowledge in reverse to generate images. This slide shows the difference between training and image generation. During training, the model starts with a clean image. Noise is added step by step until the image becomes pure noise. This is called forward diffusion. This process teaches the model how images break down when noise is added. During generation, the process is reversed. We start from pure random noise. The model removes noise step by step to create an image. It is important to understand this clearly. During generation, we do not add noise like in training. We only remove noise using what the model learned before. This slide explains an important concept that is often misunderstood. The model does not store images in memory. During training, the model never saves photos that it has seen. Instead, it learns patterns and relationships. It learns what shapes look like. It learns what objects look like. It learns how parts of an image relate to each other. For example, it learns that faces usually have eyes in a certain position. It learns that animals have specific structures. It learns how lighting, shadows, and perspective usually behave. All of this knowledge is stored as probabilities inside the model. Not as pictures, but as learned rules. You can think of it like learning a language. You do not memorize every sentence you read. You learn grammar and structure. The model works the same way. It learns visual grammar, not individual images. When the model generates an image, it is not copying anything it has seen before. It is using learned patterns to guide the noise removal process. That is why results can look familiar, but are still new images. This is why changing the prompt changes the result. The prompt activates different learned patterns inside the model. That is also why the same model can generate many different images, even though it was trained only once. So far, we talked about diffusion in a simplified way, as if it happens directly on images. In reality, most modern diffusion models do not work directly on pixel images. Instead, they work in something called latent space. Pixel space is the image as we normally see it. It is made of pixels, with width, height, and color values. Latent space is a compressed representation of that image. It keeps the important structure and information, but removes unnecessary detail. You can think of latent space as a simplified version of the image that is easier for the model to work with. To move between pixel space and latent space, the model uses a VAE. VAE stands for Variational Autoencoder. The VAE has two main jobs. First, it encodes a pixel image into latent space. Second, it decodes a latent image back into pixels. During image generation, diffusion happens in latent space. After the denoising process is finished, the VAE decodes the result back into a visible image. Working in latent space makes diffusion much faster. It also uses less memory and less computing power. This is why models like Stable Diffusion can run on consumer graphics cards. Without latent space, image generation would be much slower and more expensive. In Comfy UI, this is why we see nodes like VAE encode and VAE decode. When we generate images from text, the model works in latent space, and VAE decode converts the result into pixels we can see and save. This also explains why image resolution and VAE selection can affect results. Now we look at how text prompts influence image generation. The prompt does not act only once at the beginning. During diffusion, the prompt is used at every denoising step. At each step, the model checks whether the image is moving closer to what the text describes. You can think of the prompt as guidance. It gently nudges the image in the right direction while noise is being removed. This happens repeatedly, step by step, until the final image is formed. CFG stands for Classifier Free Guidance. CFG controls how strongly the prompt influences the denoising process. With a low CFG value, the model follows the prompt loosely and allows more randomness. With a high CFG value, the model follows the prompt more strictly and forces the image to match the text more closely. Here is a quick example. You can find CFG here in the K sampler. Too low CFG can produce images that ignore the prompt. Too high CFG can produce images that look unnatural or over-sharpened. CFG is like telling the model how strict it should be about your instructions. The prompt does not generate the image by itself. The prompt only guides the noise removal process. The image is still created by diffusion in latent space. As you can see, with CFG1, the cat is still a cat, but it is not red like we asked. With CFG7, the result is much closer to the prompt. That said, this also depends on the model we are using. Smarter or better trained models tend to follow the prompt more accurately. In fact, there are some models where we intentionally use a fixed CFG value of 1, which effectively ignores the negative prompt. However, pushing CFG too high can damage the image. It can introduce artifacts or make the result look unnatural. Because of that, we always try to find a balance. The goal is to use settings that give us the quality we want in the shortest amount of time, without hurting the final image. Now we talk about seeds. Seeds are very important for understanding consistency and variation. A seed defines the starting noise used to generate an image. You can think of it as the initial random pattern the model starts from. When diffusion begins, the model always starts from noise. The seed decides exactly what that noise looks like. If you use the same prompt, the same settings, and the same seed, you will get the same image every time. If you change the seed, you change the starting noise, and the final image will be different. The prompt guides the process, but the seed decides the starting point. Different starting noise leads to different results, even when everything else stays the same. You can think of the seed like rolling a dice before starting. If you roll the same number, you start from the same situation. If you roll a different number, the outcome changes. This is a simplified explanation. The seed controls a random number generator used internally by the model. You do not need to understand the math behind it. You only need to know that seeds control repeatability. Let us put it into practice. The seed is this number here. It can start from 0 and go up to a very large number, so each seed can produce a slightly different result. If you also change the prompt and settings, you can get millions of different results. We can control the seed behavior. If we set it to fixed, we generate once and the result will never change. To generate something new, we need to change other settings. If we choose increment, after each generation the seed number will increase by 1. If we choose decrement, after each generation the seed number will decrease by 1. So let us change it to fixed and set the seed to 10. When I generate, I get this robot. Now let us change the seed to 15. You can see that I get a different robot, this time in profile. If I change the seed back to 10, I get the previous robot again, because we used the same prompt, the same settings, and the same seed. In prompts, the order of the words matters. With this prompt, I got this image because house was first. So the model focused on the house and mostly ignored the car. With newer models, this happens less often, but this is an older model, so the effect is more noticeable. Now look at what happens if I put car first, and then house. This time we clearly get both a car and a house. Words that appear earlier in the prompt usually have more influence than words that come later. You can think of the prompt as a list of priorities. The model pays more attention to the beginning and gradually less attention as it moves toward the end. On top of that, some words can carry more weight, either because of how the model was trained or because we explicitly give them extra emphasis. Because of this, two prompts with the same words, but in a different order, can produce noticeably different results. Think of the prompt like giving directions to someone. If you say, a red cat sitting on a chair in a room with soft lighting. The most important idea is red cat. Everything after that adds detail, but the core idea comes first. We can also add more weight to a word by using round brackets. Right now, house has more weight, so the model pushes the car into the background and it is no longer the main focus. If I add even more brackets, the influence of house becomes even stronger, and now the car disappears completely. If I instead add more weight to the word blue, you will see more blue appear in the generation. One more thing you might notice is that there is no spell check by default. Sometimes it can be useful to turn it on. To do that, go to Settings, search for Spell, and enable Text Area Widget Spell Check. Now, words that are misspelled or not part of the dictionary will be underlined. Now we talk about denoising steps. Steps control how many refinement passes the model performs during generation. Each step removes a small amount of noise. The image is not created in one action. It is refined little by little, step by step. When you increase the number of steps, the model has more chances to clean up noise and add detail. When you decrease the number of steps, the process is faster, but the image can look rough or incomplete. More steps means slower generation and more refinement. Fewer steps means faster generation and less refinement. There is always a balance between speed and quality. You can think of steps like polishing an object. More polishing gives a smoother result. Less polishing is faster but rougher. In Comfy UI, steps are set inside the K-sampler node. For most models, a good starting range is between 20 and 30 steps. Going much higher often gives diminishing returns. Going much lower is useful for fast previews. Steps work together with the seed and the prompt. The seed decides the starting noise. The prompt guides the direction. Steps decide how far the refinement goes. Now we are ready to look at a real workflow in Comfy UI. This is called text-to-image, often shortened to text-to-img. Text-to-image means we start from pure noise and generate an image only from text instructions. There is no input image involved. This is usually the first workflow people learn, and it is the best way to explore ideas and styles from scratch. We start by loading a model. This model contains everything the AI learned during training. Next, we give the model instructions using a text prompt. This describes what we want to see in the image. We also define the image size using an empty latent image. This decides the resolution before the image is generated. Then, the K-sampler runs the diffusion process. This is where noise is removed step by step, guided by the prompt. After that, the VAE decodes the latent result into a visible image. Finally, the image is saved to disk. Use text-to-image when you want to explore new ideas, you want to test prompts and styles, or you are starting from nothing. This workflow is ideal for concept art and experimentation. But we can also start from an image, not just from pure noise. In that case, instead of beginning with random noise, we use an existing image as the starting point and apply denoise on top of it. You can think of denoise as how much freedom the model has to change the image. With low denoise, the model stays very close to the original image. With higher denoise, it moves further away and behaves more like text to image. So rather than generating everything from scratch, we are guiding the diffusion process using an image as the base, and then controlling how much it changes using the denoise value. Image to image is like starting with a rough sketch and deciding how much you want to redraw it. You can see that in the text-to-image workflow, we have empty latent image. That node generates the noise. In this workflow, we have an image that is encoded to latent so it can go to the K sampler. Let me show you how I did it. I removed the empty latent image node, then I double-clicked on the canvas and added a load image node. From here, we can load an image, and I will choose this robot. Now you can see it does not have a latent output, so we cannot connect it to the K sampler yet. So we need a VAE. If we look, we have decode and encode. We already have VAE decode when it converts from latent to pixels. Now we want to encode it. An easy way to find the right node is to drag a link and release it, and you will see a suggestion for VAE encode. Now we have a latent output, which means we can connect it to the K sampler, which is what we want. If we try to run it like this, something is missing. It says, missing VAE. You can see a big red outline around the node with the problem, and a small circle around the input, which means we need a connection there. So let us connect it to the VAE. In this case, the VAE is included in the main model, so we connect it from there. Now we encoded it, and then we decode it. Let us run again, and now it works. But the result is still different from my input. We have the right prompt, but something is influencing it. Remember this. Every time you use an image as input, we need to adjust the denoise, because that controls how much the image changes. With the default value of 1, it is at the maximum, so it changes the image too much. Let us change it to 0.2 and see how that affects it. Now you can see it is very similar to the original. It is hard to tell what parts changed. Let us increase it to 0.5. Now we can see more changes in the robot face. There is an easy way to compare these images. Double-click on the canvas and search for Image Comparer. This is part of the RG3 node pack. You can see it has two inputs, image A and image B. I want to compare the original image, so I will connect the load image output to image A. For the second image, remember the Save Image node is only for saving to disk. The image we want to compare is the one coming out of VAE decode, so we connect that to image B. Now let us run the workflow. We get this small preview. Let me make it larger. It is still too small, so I will move some nodes to make space so you can see it better. By default, it shows image A, the original. When we move the mouse over to the right, it shows the second image. Now it is much easier to compare before and after. If I change denoise to 0.1, we get a very similar result, because the amount of denoise is small. If I change it to 0.9, we get a big variation. All of this is also influenced by the sampler, the scheduler, and the model itself. But in general, this is how it works. I prefer to start with values around 0.7. If that is too much, I reduce to 0.5 and keep adjusting until I like the result. Another thing you should know is that the input image size influences the result size. Since we do not have an empty latent image node where we set width and height, the loaded image decides the size. Comfy UI will also round the size to a multiple of 8. For example, if your image is 511 pixels, it can be rounded down to the next number that is a multiple of 8, like 504. You can also control the input size by resizing or cropping it, like you saw in the earlier chapters. For example, I can add an upscale image node here, then redo the connections so the image passes through it. I can upscale to a bigger size with the same ratio. Now when I run it, the final image should be larger, because it follows the input image size. Now we are going to talk about samplers and schedulers, which you can find here in the K sampler. This is one of the most confusing parts at first, but the idea is actually simple. Everything begins with the same initial noise. The seed defines that noise, but once the noise exists, two different systems control what happens next. The sampler decides how noise is removed. It defines the strategy the model uses to go from noisy to clean. Different samplers use different mathematical paths to denoise. Some remove noise more directly. Some refine the image gradually. Some are more random and creative. Some are more stable and precise. Even with the same prompt, the same seed, and the same number of steps, changing the sampler can change the final image. So the key idea is this. Sampler controls how each denoising step is calculated. Or in simple terms, sampler equals how noise is removed. The scheduler does not change how denoising works. It changes when denoising happens during the steps. A linear scheduler spreads denoising evenly across all steps. Each step removes roughly the same amount of noise. A nonlinear scheduler removes noise faster at the beginning and slower near the end. This allows fast structure early and fine detail later. Both approaches can reach a clean image, but they feel different in how detail is introduced. So the key idea here is scheduler controls when noise is removed. Or simply, scheduler equals when noise is removed. Sampler and scheduler always work together. You never choose one without the other. The sampler chooses the denoising method. The scheduler chooses the timing of that denoising. The same noise, plus a different sampler or a different scheduler, can produce different results. Let us do a little experiment in Comfy UI. From Workflows, I open again this text to Image Workflow, and I change the seed to Fixed. Then I run the workflow. With this sampler and scheduler, we get this robot. Here we have a lot of samplers and schedulers. Depending on the model we use, some work better than others. Let us say I pick the Euler sampler. Now when I run it, even if the seed and prompt are the same, the result is slightly different, because the sampler influences how the denoise is applied. Let us say I also change the scheduler to Simple. Now the result will again be different, because the scheduler changes when the denoise happens during the steps. Because the model we use is quite small, we can actually preview multiple results at the same time. So I hold the Control key and drag over these three nodes. Then I use Ctrl+C to copy them, and Ctrl+Shift+V to paste them with the links connected. Now this workflow will generate two images and has two K-sampler nodes. Let me use Ctrl+Shift+V again to get a third one. Now this workflow uses the same seed and prompt with three different K-sampler nodes, and I want to change the samplers and schedulers for each one. You can play with these all day and try many combinations. I will choose something random for this example. Now when I run it, you can see it generates an image for each sampler. Some results are quite similar, but some details are different. For example, parts of the robot may change from one image to another. Let me now put the same sampler on all of them and use different schedulers only, so we can see how the timing of denoise influences the result. Again, the differences are subtle, but they are there. Sometimes this can mean one image has 5 fingers and another has 6, so having options is useful, especially when you want small variations. Now let us double-click on the canvas and add a primitive node. I want to control the steps value for all 3 K-samplers, but I do not want to change it manually on each one. So I drag a connection from the primitive node to the steps input of the first K-sampler, then do the same for the second and the third one. Now from this single node, I can control all 3. If I change steps to 1, you can see we get very similar results. If I change steps to 3, you can already see differences. Some schedulers are faster. For example, with one scheduler, the image is still very noisy, while with another, you can already see a shape forming. If I change to 4 steps, the differences become more visible. At 5 steps, some start to form clearer shapes. At 6 steps, some images already show eyes and a main structure. At 8 steps, the middle one is almost fully formed. At 10 steps, almost all of them have something that could work for certain concepts. And at 20 steps, most of them have enough detail to be usable in a project. Usually, the people who create AI models suggest specific samplers and schedulers, or the community tests them and shares which ones work best. This way, you do not have to test everything yourself for every model, but if you do find good settings, it is always a good idea to share them with the community so everyone can improve their image generation results. Let's talk a little about subgraphs. In Comfy UI, go to Workflows and open the Juggernaut text-to-image workflow. Here you can see a bunch of nodes, just like before. Hold the Control key and drag to select most of the nodes, except the Export node, which in this case is the Save Image node. Now that the nodes are selected, look at the icons at the top. One of them says Convert Selection to Subgraph when you hover over it. When you click it, all those selected nodes are combined into a single node. If you right-click on this new node, you will see an option called Unpack Subgraph. When you click it, the nodes go back to how they were before. Let's do it again. Select 2 or more nodes, then use the Subgraph button to create a subgraph. Resize it so it is easier to see. A subgraph is a way to group multiple nodes into a single reusable block. Instead of showing a long chain of nodes every time, you collapse them into one node that represents an entire process. You can think of a subgraph like a function or a macro. Inside it, there can be many nodes, but from the outside, it looks simple. It is very similar to Smart Objects in Photoshop, which can contain multiple layers inside a single object. Subgraphs solve 3 main problems. First, they reduce visual clutter. Large workflows can become messy very quickly, and subgraphs help keep things readable. Second, they help reuse logic. If you repeat the same setup many times, like a prompt encoding chain or an image preprocessing step, you can reuse it instead of rebuilding it every time. Third, they make workflows easier to explain and share. People understand a few clean blocks much faster than dozens of individual nodes. At the time I recorded this tutorial, subgraphs were still being improved and may still have some bugs. A subgraph does not make a workflow faster by itself. It is about organization, not performance. Performance depends on the nodes inside the subgraph, not on the subgraph wrapper. A subgraph is like putting many Lego pieces into one box and labeling the box with what it does. All the pieces are still there, you just do not need to see them all the time. You can see the title says New Subgraph. Let's double-click on that and rename it to something that makes sense, like Text to Image, and maybe also include the model name. So Juggernaut Text to Image. Now it looks like a simple workflow with only 2 nodes. I do not like the order in which things appear in the node, so let's right-click on the node and select Edit Subgraph Widgets. Here you can choose what parameters to show in that node and what to hide. Let me hide all of them so we have a clean subgraph that does not show any parameters. You can enable them one by one later if you want only the ones you need, but we will build those manually so you understand them better. Let's close this panel. Now let's go inside the subgraph. You can see that all the nodes are there, plus some input and output. On top, you can see a new tab next to the workflow name. If I click on the main workflow name, that is how we exit the subgraph. From there, we can go back inside, and from inside, we can go back outside. You can see the output where the image is saved. If we go inside the subgraph, that image output appears here as a link. From this dot, we can drag a connection to where it says checkpoint name. Now that field becomes gray, just like when we added a primitive node before. If we go back outside, you can see that the checkpoint name appears here. Let's go back inside again, double-click on that name, and rename it to model to see what happens. Now when we go back to the main workflow, you can see it says model instead of checkpoint name. So this is very customizable. Let's go back inside and drag another connection, this time to the positive prompt, and rename it so we know what it is. Do the same for the negative prompt. Now when we go back outside, we have positive and negative prompt visible. Go back inside again and drag connections to width and height, and maybe do the same for all the parameters from the K-sampler. Now we can see all those parameters exposed here, and when we go back outside, we have this single node that acts like a mini interface that can control everything we need. You might say that it looks nice, but does it actually work? Let's try it. And the answer is yes, it works. If you right-click on it, you can see it still has other options, like node color, bypass, and so on. With that subgraph selected, right-click on the canvas this time, and you will see an option called Save Selected as Template. It asks for a name. I will name it Juggernaut Text to Image, then press Enter or Confirm. It looks like nothing happened, but where was that template saved? Let's open a new workflow. Now right-click on the canvas and go to Node Templates. You can see that name there now, and you also have the option to manage templates and remove them. When I select that template, it is added to the canvas with all the nodes, connections, and settings it has inside. Now we can just drag a link from the image output and add a Save Image node, or connect it to other nodes to create more complex workflows. Over time, this simplifies workflows because we can organize them into pieces and group them by category or function. Let's go back to the first workflow, just to show you that any node or combination of nodes can be saved as templates. There are cases where some connections can break when some nodes are inside a subgraph and others are outside, so keep that in mind. For example, I use this Pixaroma Note node a lot. I want to save it as a template so I can access it easily next time. This might not be useful for everyone, but as a workflow and tutorial creator, I use this a lot. I will save it as a template and give it a name. Now I can go to any other workflow and quickly access that template from anywhere. You can also have subgraphs inside other subgraphs, like boxes inside boxes. You can disconnect or remove links at any time. I could select two nodes here and combine them into another subgraph, or go outside and combine all these nodes, even if some are simple nodes and one is already a subgraph, and it will still let me create a new subgraph. If we go inside, all those nodes are there. If we go back outside, we can unpack it using the icon, or right-click and choose Unpack Subgraph. These things will make more sense as you work with them in practice, so play with them and have fun. When you see that icon on a node, you know it is a subgraph. It also has the icon that lets you go inside the subgraph, which is another indicator that it is not a simple node. Remember that you can also use the interface to edit subgraph widgets. One thing I forgot to show is that you can use those dots to rearrange the order of the parameters shown in the subgraph node. This way, you do not need to go inside it most of the time. You can control things directly from the outside.